Welcome back. We're going to continue our lessons on RF1 quadratic functions. So we talked about standard form in the last video. We described what A, B, and C did. Right? As a quick recap, we said A told us the direction of opening, and it also told us the stretch factor. How wide or how narrow is this parabola going to be? We said that C told us the y-intercept. Right? Where does our graph hit that y-axis? And then B influences the vertex. B doesn't directly tell us a specific value. We can use B to calculate values, but it doesn't tell us anything on its own. So we're going to practice using our calculator how we can graph some of these functions to identify their characteristics. So we're going to be looking at the function x squared plus 6x plus 5. The first thing we should always be doing to help us out is pulling out those a's, b's, and c's. So a here, because I see nothing in front of the x squared, means it's a positive 1. B is a 6, and C is a positive 5. So first thing first, we ask ourselves, what's the direction of opening? Well, because A is positive, we already know that this graph is going to open up. For the rest of it, let's use our calculators to find some of these values. So I'm going to pull up my graphing calculator. And if you have a TI, you can follow along. My buttons are going to show up. Whatever buttons I'm pressing will show up down here. And then this is just a wider view of my screen. So on a TI, these 5 buttons up at the top, these are your graphing buttons. So if I want to enter a new graph, I'm going to go to y equals. If there's anything there, you can just hit clear to get rid of it. And we're going to enter this function. So to enter a new function, I'm going to hit x squared, right? Notice my x variable button is that one highlighted red right now. Plus, and let me just check our function, 6x plus 5. And then I'm going to go ahead and I'm going to hit graph in the top right here. So my graphing window is in its standard settings. If your graph doesn't quite look like this, I want you to hit zoom and then hit the number 6. See how it says number 6 is zoom standard? That's our basic window settings. What that does, and if we click window, it just gives us essentially a 10 by 10 view. It lets us see negative 10 to the left, positive 10 to the right for our x, mins, and max, negative 10 down, and positive 10 up for our y's. So we can see our parabola here. We want to get a good view of this parabola. We want to be able to see all those key characteristics, right? Our x-intercepts, like these points here, our vertex, like this point down here, our y-intercept, like this point up here, right? Those are our key points. So we can see our vertex, right? But it's hard for us to get exactly there. So to find any values, and I'm going to clear this again, we're going to go second and then trace. Notice it says calculate above. That's taking us to this calculate menu. The buttons we're going to be using are these first 4 options. Number 1, where it says value, is going to be able to give us a y value. Number 2, where it says 0, is going to give us our zeros. Those are also our x-intercepts. And then 3 and 4 is going to give us our vertex depending on the function we have. So let's start with that because it's next on our list. I'm trying to find my vertex. If I look back at my graph, my vertex here is the lowest point on my whole graph. That means that to find my vertex in this case, I'm going to hit minimum. If I had a graph that opened down, then I would hit maximum. So your calculator gives you some instructions down here at the bottom. It says left bound. It's asking you pick a point somewhere left here. So you can use the arrows, or you can type in a number, right? We see that this is about -5. So let's try -6. Right, as long as it gives you that little arrow somewhere left of your vertex. It says right bound now. Well, 0 is to the right of my vertex, right? You can use the arrows, you can type in any numbers as long as they're left and right of this vertex. And then guess, if you're unsure, right, you can select near it, but your calculator should be able to do the work for you. And if you hit enter, it'll tell you the exact point that that vertex is at. So in this case, it looks like negative 2.99999. We can round that to negative 3. And the y value is negative 4. So again, remember your vertex is a coordinate. So our vertex has an x value of negative 3 and a y value of negative 4. When we sketch our graph on the right, sketch means represent the key characteristics through a drawing. So I can plot this point to start us off. I can go negative 3 to the left, negative 4, I'm going down. Here's where my vertex is. Axis of symmetry. So if we remember, that's the line that cuts it right down the middle. So if I was to be able to draw a vertical line right here, right, it would give me right through the middle here, it would give me a nice symmetrical, even shape on either side. And what that is, that's a vertical line through our x value. So for axis of symmetry, I'm going to put x equals negative 3. Notice that this value from our vertex, the x value of our vertex, is always going to be the equation of our axis of symmetry. Because if I'm talking about the middle of the parabola, right, where is it symmetric on either side, it goes right through the vertex. Now let's find some x and y intercepts. So again, finding more values, I'm going to go back to that calculate menu. All right, and this is where I'm going to go. So that second trace, every time I want to find a specific point or a specific value on the graph. So again, like I said, value. If I hit value, so I can hit 1 or I can just hit enter, it prompts me with an x equals at the bottom. So I can plug in an x value and it's going to tell me the related y. If I wanted to, right, we notice, remember that negative 3 was our vertex. It tells me that at negative 3, y is negative 4. So it's just going to tell you any point on the graph. What we're going to specifically use it for, and I'm going to go to that menu again, is I want to find a y-intercept. So right here, right where I hit that y-axis, I know that a y-intercept has an x value of 0. That's what puts it on the y-axis, right? It means we haven't moved left or right at all from that middle line. So it'll tell me right now that when x is 0, y is 5. So that's going to be my y-intercept. And if we remember, that's actually our c value as well, right? Our c value, the constant term, told us our y-intercept. So it's just another way to find it. My x-intercepts are going to be a little trickier. So again, I've done value, right? I found my y-intercept. I've done the minimum. I found my vertex. And now I'm going to hit 0. Right, because our x-intercepts can sometimes be called roots and can sometimes be called zeros. So it's going to, again, prompt me to go left and right of whatever point I'm trying to find. Well, now I'm trying to find an x-intercept. And if I want to find, let's do this x-intercept first, the one on the right here. I want to make sure that I pick some point to the left of that x-intercept and some point to the right. Right? You can type in numbers or you can use the little blinking cursor. As long as I have a single x-intercept between those two lines, it's going to tell me what it is. I want you to be extra careful that you're not accidentally surrounding both of your x-intercepts. Right? You don't want to go left of the first one and then right of the second one, because then your calculator won't be able to choose, right? It doesn't know which x-intercept you want. So we're going to kind of zoom in essentially. Right, I've put these bars only around this x-intercept. We're zooming in on one at a time. And so it tells us we have one at negative 1, 0. And then we'll find our last one. Again, I'm going to go back to that menu. I'm finding a new number. I go through the whole process again. I need to pick somewhere now. I want to go all the way left of this leftmost x-intercept, right? Any of these points are fine. And then I want to go right, but again, I want to make sure I don't include the x-intercept I already found. I just want to zoom in on one of these x-intercepts at a time. And so I get negative 5, 0. So these are all points we can now plot on our graph. I'm going to plug some of those in. So I have a point at negative 1. I have a point at negative 5. I have a point at 0, 5. Right? And because of symmetry, if I wanted, I could also point a point here, right? 1 over and 5 up from that point on the left, because it needs to be the same on both sides of that vertex. Right? Our axis of symmetry runs right through the middle here. Everything on the left side should be a reflection of everything on the right side. It's never going to be a lopsided function. And so I can connect those points as best as I can. Right, and we get this parabola shape. We try to connect all the points. It's a little iffy on my touch screen here, but hopefully you can do it better on pencil and paper. And again, this line, right, your axis of symmetry, is just an imaginary line. It's just to help you. It's not a real part of the graph. It's just a characteristic about the graph. So you don't necessarily want to include it. Or if you do, I'd recommend drawing a dotted line. The last thing is the domain and range. So remember, domain talks about the x's. The way we tend to write this is we say we have x's in this graph. So we write curly bracket because it's a set of numbers, so it's a set of information, x's. And then we draw a line, and this is the such that line, right? It means we have x's such that, and then we describe what x's we can have. Well, in this case, if I'm looking at this graph, right? Yes, I have points at negative 3 and negative 5 and negative 6. But as my graph continues up, my graph is going to continue left forever and ever. There's nothing stopping this graph. And same thing on the right side of my vertex. As it continues up to the right, it's also going to keep going outwards to the right. The way we write this is we say x, this fancy e means is an element of, and then we draw this fancy r, which is the set of real numbers. So if you remember from last year, real numbers are basically all the numbers we can think of. It's all those rational numbers. It's also all the irrational numbers, right? It's any possible number we can think of. The only thing that isn't a real number is when we get into imaginary numbers, and we don't look at those in this course. So we're just saying this is our really fancy way of saying x can be anything. X is all real numbers. The range, we do the same idea, but we say we have y's in this graph, right? Ups and downs, such that. And this time, we have a minimum, right? Every other point on this graph is larger than that lowest point. My graph never goes below that vertex point. So the way we write that is we say that all of the y's in this graph are greater than or equal to negative 4. Because they are, right? Negative 4, this vertex here, this is our lowest point, our lowest y value of negative 4. If I look at my graph at negative 5 and negative 6, right, there's no parabola there. My graph isn't going to reach there. But it does keep going up forever and ever and ever. So it's every number that's bigger than negative 4. And then we add on the extra piece of information saying that when I'm saying all numbers bigger than 4, I mean all the real numbers. I mean none of the imaginary numbers. And we're going to notice another pair. This number here, this range value, is always going to come from the y value of my vertex, right? Because that's going to either tell me the minimum point, the lowest point I go, or the maximum point, right? Sometimes if my graph opens down, I'm going to have a highest point. So these are the main characteristics that we're going to analyze for every single parabola we look at. So let's try to do one more. Again, first thing you should do, identify A, B, and C. So A, in this case, is negative 1, right? Notice we have that negative in front of the x squared. B is 2, and C is 3. So what does that negative 1 tell us? That negative 1 tells us that we're going to open down, right? A negative a value tells us our parabola will open downwards. Again, we want to graph this to find most of our characteristics. The only other thing I could find at this point is my y-intercept. Because I know my c value, because I was in standard form, I know that I have a y-intercept at +3 already. But let's pull up our graph, practice these skills. So we're going to go back to our y equals menu. I'm going to clear this. And we're going to plug in this new function. So it's negative. Make sure you start with the negative button, this one down at the bottom, not subtraction, or else you'll get something called a syntax error. So it's negative x squared plus 2x. Go plus 2x plus 3. And I'll hit graph. And so just like we guessed, right, it opens down. We see that y-intercept at +3, so we don't even need to calculate that one, we know it. And then we want to find our two x-intercepts and our vertex. We always want to use the calculate menu because we don't want to assume that it's a nice integer value, right? These x-intercepts, it pretty much looks like the left one is -1 and the right one is +3. But what if it's -1.1, right? Or 3.05? We want to make sure we're exact. So I hit second, trace. We'll do x-intercepts while we're here, right? I pick somewhere to the left of 1. I pick somewhere to the right of that same 1. And then it tells me the x-intercept that was between those two lines I gave it. So -1, 0, right? And we were right with our guess. Another place we can always check is our table. So see on the top right side, the graph button here, it says table above it in blue. So if I hit the second button first, it gives me a table of values, just like we created in the very first example. Right? And if I have nice integer numbers, I'm going to notice, right, at points like this, when x is 1, y is 0. The fact that y is 0 means I'm representing an x-intercept. I can see here that when x is 3, y is also 0. So there's another point I can pull out. However, the table's not going to work for you if your x-intercepts aren't at nice integer values. We can see our y-intercept here as well. Right, when x is 0, y is 3. We don't know which of these points is our vertex, so let's go back to our calculate menu. And this time we're going to hit maximum, because now my vertex is the highest point on my graph. It's the maximum my graph goes. Again, I pick somewhere left. You can use the cursor. You can also type things in, right? Obviously, I know that it's somewhere between 0 and 4, so I could do that. And then we hit enter on the guess, and it tells us it's at 1. Again, we can assume that we're rounding those zeros. If they're not zeros, if it was like 1.22222, I'd want to call it 1.2. So we're at 1, 4. My axis of symmetry, remember that cuts through the x value of my vertex. We write it as an equation because it's a vertical line. It's not just a point, it's a whole line. So at 1, 4, here's my vertex. At -1, 0, here's an x-intercept. Oops, sorry, I put that at 1, 5. There we go. 3, 0, there's my other x-intercept. I can connect those. I'm going to put arrows on the bottom just to show you guys that my graph does keep going forever. My domain, I say I have x's such that, and I'm going to start to realize that every single time my domain is x is an element of the real numbers. Because every single time my graph is going to go infinitely far left and infinitely far right. My range, on the other hand, depends on where my vertex is. Right? Remember we said that it came from the y value of our vertex. So yes, it's still going to be a +4. But this time, because my graph opens down, I want to make sure I'm clearly saying that every value below -4 is part of my graph. When my graph opens down, I'm going to use this less than or equal to sign, because every y on this parabola is a number 4 or smaller. And we clarify that those y's are real numbers. I want you to give the rest of the examples a try, see if you can use your graphing technology. If you're struggling with your calculator or you use a different model of calculator, please let me know and I can give you a hand with that.